Hello everyone, it's Susan here and I'm going to answer another question from paper 1 2022 A-level maths, pure maths at Excel. In this question we have a parallelogram and we know the vector PQ is equal to 2i plus 3j minus 4k and vector QR is equal to 5i minus 2k. In part A, we need to show that PQRS, which is a parallelogram, is also a rhombus. In order to prove this shape is a rhombus, we need to show that the size of the sides are equal with each other. So, therefore, I'm gonna find, so in a rhombus, they have equal sides. So I'm gonna find PQ, size of the PQ, which is equal to 2 to the power of 2 plus 3 to the power of 2 plus 4 to the power of 2, which is equal to the square root 29. And QR, the size of the QR would be equal to 5 to the power of 2 plus 2 to the power of 2, which is also equal to 29. Therefore, this shape is a rhombus. Okay. In part B, it says find exact area of PQRS. For finding the exact area of PQRS, we need to work with a bit with the vectors. Okay, first I'm gonna draw the diagonals of this rhombus because I know the area of the rhombus would be half of the diagonals multiplying by each other. So here is going to be half of the QS times by PR. That means I need to find the length of the QS and PR. Okay, so I'm gonna just I'll put the sign of the vector on the sides and on the sides of this rhombus, and also as we know the size of each side are equal with each other, so I can actually write next to them what would be their vectors. So 2i plus 3j minus 4k, SR it would be the same, 2i plus 3j minus 4k, and QR would be 5i minus 2k, and PS would be the same. And we also know at the point that diagonals meet each other, they form 90-degree angles. Now I need to write the vector PR. So let's look at the vector PR. So this is the vector PR. I can write that as an addition of the vector PQ, vectors PQ to QR. So that would be the column vector 2, 3, minus 4 plus 5, 0, minus 2, which would be equal to 7, 3, and minus 6. Now I need to find vector QS, this vector. So for finding a vector QS is going to be vector QR minus vector RS. Okay, okay, that's it. So I'm going to write it here. QS is equal to 5, 0, minus 2, minus 2, 3, minus 4, because you saw that we moved opposite the direction of the vector SR. So therefore the column vector would be equal to 3, minus 3, and 2. Now I need to find the size of the lengths of each of these vectors. Therefore PR would be equal to a square root 7 to the power of 2 plus 3 to the power of 2 plus 6 to the power of 2, which is equal to a square root of 94. And QS would be, the length of the QS would be equal to 3 to the power of 2 plus 3 to the power of 2 plus 2 to the power of 2, which would be equal to the square root of 22. Now we have all information that we need to find the area of the shape, and as I said, area is equal to half of the length of the QS, which is a square root 22 times by PR, which is a square root 94, and the final answer would be a square root 570. Thank you, and by answering in this way you can get the full mark for this question.